Welcome to 8th grade math, rate of change, where we will talk about TEK 8.3a, where we will use graph tables and algebraic representation to make predictions and find solutions to application problems using appropriate tables, graphs, and algebraic equations. Mr. Taylor here, and I want to introduce you to a concept that is very close to a sequence that we just covered, and this concept is called the rate of change. You should already know about what a rate is, and if you do not, we said that a rate is some ratio with a denominator of 1. Okay, so let's get in here, and this video here will be just pretty much as an introductory concept before we really get off into some challenging word problems. So as we take a look, we're looking at a table here, and this table is showing participants in of 8th graders in a school sports program for 3 consecutive years. Well, as you can see, we have year 1, 2002, there were 70 participants in the school. Year 2003, there were 75 participants. Year 2004, there were 87 participants. And year 2005, there was 105 participants. Okay. So, what do we mean by rate of change? So, rate of change, again, is some ratio where the denominator is always 1, and you're comparing the numerator to that particular denominator. To be able to find the rate of change between 2 data points, it said you want to divide the difference of the y coordinates by the difference of the x coordinates, and the rate of change between x sub 1 and y sub 1 and x sub 2 and y sub 2 is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So what is this telling us when we see this data? As we go back and look at our particular table that we have constructed to determine the 8th graders in the school program, we see that years, we have named it our x values, and participants, we have named that our y value. Just for you to see briefly what that looks like from a graph standpoint, if we were graphing in a coordinates plane, and what I'm going to do is just show you the positive side and not both sides. We will look at, this is our x, this is, oh no it's not, no, this is our y, and this is our x, the horizontal versus the vertical. So horizontal is x and vertical is y. And what we will do on here is we will have participants being these particular, so participants or participation. Participation is our y, and then of course years would be our x. And this is how we see that on the graph per se, and just going in literally grafting the numbers. Wish I would have left a little room there, but we'll get a chance to look at that really good. So what I've done, just to get you begun, just to get you started, and I'm going to go ahead and move that out of the way right here that I just constructed, because I want to use the space. I purposely created it to use this particular space. I'm sure you've already put that in, but to look now to make sure that we understand what we were talking about when we said y sub 2 minus y sub 1. And I don't think I put it down here. Yes, I did. I did put it down here. But here's what we're saying. We're saying that we will take our y values, which is y sub 2 minus y sub 1, and we will divide those by our x value, which is x sub 2 minus x sub 1. And now looking at the chart, we see that again, this is y. This is in the first position. This is the second position. So we will take 75 minus 70, and that's going to be divided by 2003 minus 2002, and that can be simplified to 70 from 75 leaves 5, and 2003 minus 2002 leaves 1. So between 2002 and 2003, there was an increase of 5 students. Let's take a look at the next one briefly. We have 87 minus 75 over 2004 minus 2003, and that's going to give us, this is where I got the 12 over 1. So again, between 2003 and 2004, that was an increase of 12. And then let's just go with 2005, which will be, no, I'm putting that on there. We can go ahead and put it there. It's not going to kill us. 2005 minus 2004, and over that we'll put 105 minus 87, and that's going to give us 18 over 1. So we have our rates per year: 5, 12, and 18. And this is just showing us, and we're not really getting into a constant right now, but just showing us what other changes between the years involved and the participants. Now there are some questions that we can answer once we get this set up, and those questions would be, just simple questions that we could just look at and say, hey, what can we do with this information that we know? Well, let's see, can we take a look at it and see, can we answer some questions? Say, for instance, looking at this data that we just created, say for instance we say, between which 2 years was the greatest increase in the number of participants? So looking at what you constructed with 5, 12, and 18, you can easily say between 2004 and 2005, that was an increase of 18 students. So that would answer that question. Then it would say, let's look at, say, between which 2 years were the least amount of students, or least amount of participants, or the increase. So then you can look at 2002 and 2003, and there were only an increase of 5. So this would be the greatest, this would be the least. And then if they, let's think about this. How would you find the average increase between 2002 and 2005? Well, there is an answer for that. What you would do easily is just now look at the difference between 105 and 70, and here you will get 35 if you subtract 105 minus 70, and then you're going to put 205. So we would have, I'm just going to say 2005 minus 2002, and what that's going to give us is 35 over 3. Now we're not completed with that because we need to reduce it, and 3 goes into 3 one time, and then into 5 one time. So it's probably be about 11.6 or 11.7, and I'm just estimating. I didn't really put the math to it. You can do the math and see what it is. But again, you can see that using this rate of change in this tool, we can answer several questions on our test or just in real life. Okay, so we will take up with rate of change as we go forward. I just wanted to pretty much give you this little pre-teach introductory to rate of change, and I will definitely see you soon.